So acid deposition, which you commonly reference as acid rain, and the reason the term is different is because it can fall as a, believe it or not, as a solid dry particle, okay? Because, which doesn't make any sense to me at all because it reacts with water, but I guess something happens and it becomes heavy, and so they call it like a dry acid particle. But what reacts? And the pictures will tell you right there. What starts acid deposition? Nitrous oxides, whoops, and sulfur oxides, and they react with water, and they form sulfuric acid. And correct. And there's a picture of dry and wet deposition. And then here's a pH scale. On the AP exam, you would have to know normal rainwater is 5.6. Pure water is 7.0. Above that is what they consider the normal pH for ocean water. And anything, whoops, below 5.6 is considered acidic fall. Some consequences to acid deposition. What do you think is mostly affected? Crops, definitely. So plants or any really single-celled organisms are going to be affected by rapid changes in pH. I put this here. You don't have to know this on the test at all, like what standard pHs are, but I'm sure that they can give you some kind of graph and then reference it to acid deposition. So what organisms would be affected by acid rain? Because these are their normal pH living conditions or their tolerance. So snails can tolerate only up to 6.0. So if you go anything below that, they're going to be affected. Does that make sense? So that would be the type of, no? Yeah. Oh, okay. What else is affected by soil? Definitely, okay? Because what's going to happen if the soil is acidic? Plants are going to take it in, and then the whole entire ecosystem is affected because the food chain is affected. And then damage to structures. So if you look at like anything that has concrete changes to like a greenish color, or it starts to deteriorate. So we're in indoor air pollution now. We were outdoor, and you want to take into consideration that pollution indoors is more serious because why? There's nowhere for it to go. So if it's here, we're going to be affected by it unless if we start opening up things and trying to air it out. So there's a lot more health risks, and it says here that people spend more time indoors than they do outdoors, so that makes more sense. So the risks are also greater. So let's talk about some of these common indoor air pollutants. And you guys should know, like 4 through 6 should be a little bit more familiar with this. Radon. Formaldehyde, which is right here. And that's the chemical formula. Which, who answered that question? Good job. What else? What do we say is part of incomplete burning? No. Oh, yeah, that too. Carbon monoxide, good. Or tobacco smoke. And what are these little things here? Particulate matter, good. Tobacco smoke obviously comes from cigarettes, but think of carbon monoxide as one of them too, which can come from any incomplete burning of carbon, and in your home it would be your fireplace, if you have a gas stove, okay, that type of thing. Radon is underground, and if you don't know this, you need to make notes of it because for some reason it's not in your notes, just a picture. It's found in uranium, and it occurs through the decay of uranium. And it somehow seeps into your home, okay? So that's how you get the radon. Formaldehyde is very highly linked to furniture and paneling. So like any kind of paneling in your home contains formaldehyde. And it's linked to Lou Gehrig's disease, which I put that there because it's come up before. We know about particulate matter, and we're going to do a particulate matter lab, which will reinforce that, and most of them lead to cancer. And here is actually a diagram of your home and all the possible pollutants. So we did carbon monoxide, And this is why I didn't go over it in the last slide, because here it is. Formaldehyde. And then there's some extra ones. Radon. So asbestos, let's talk about that, because that's definitely a question on the AP exam always, and a really important topic. I think I talk about it later on too. Asbestos was actually found in insulations. And so when a construction was built, insulation is what's inside your wall. Anybody know what it's used for? So we're going to have to learn about that in another chapter.
It's to trap what, like heat in winter.
So it's a way to make energy more efficient. So it helps reduce loss of energy, which is the goal of any type of energy system, because loss cannot be recovered, yeah? And they put asbestos in this, and then what they didn't know was that it broke apart and was emitted into the atmosphere, and people were breathing it in, and serious health issues from it, including death. So in most public schools in the United States, the people that built them with asbestos in the insulation. So public schools had to close portions of their school, and I lived through this. Still recording. So most indoor common problems: dust mites, eek, mold. I always say this when I uncover mold or talk about mold. Remember that mold is a living, breathing organism, right? Yeah, you don't want it. And mildew is this picture. And have you ever heard of a sick building syndrome? So when the building is to the point of you don't even notice, but a lot of people are getting nauseous and dizzy and getting headaches. There might be something inside the insulation, something that's causing that, and you don't even see it, but it's in the atmosphere and you're breathing it in, which leads to the sickness. And then they have to condemn it, like close the building. This would definitely be one that they let go too far, yeah. So just like water, the Clean Air Acts began in the 70s. So remember, I told you always keep that in mind if you have to choose from some questions you want to think of 1970. They came up with these national air quality standards, and you don't ever have to know like serious information about each, but you do have to know some association. And I'm going to have a whole lesson on acts. No, lead. Not really a topic that we have to worry about, because supposedly lead was removed, right? It's not really being used. Where did you mostly find lead? Paint. Still can be. What else? Pencils, which is not really something, I mean, unless if you're. But where was it our biggest problem?
Oh, gas.
Gas. So when you used to go to a gas station, you pumped leaded gas or unleaded gas. You don't see that anymore, okay? And you shouldn't. Somebody Googled the other day and found one that still exists. So when it was found in gas, it was a big problem, because what's going to happen, it's going to seep into your ground, and then all of these things can occur. These are preventions, and it already took place. The phasing out, the removal, all that. I want you to go through these diagrams in your book and just become familiar with any of the solutions to all the problems we talked about. And remember, you should always know a couple, and you're going to see that they're very correlated. And then if you have any questions, you talk to me directly about them, okay?